Hello everyone and welcome back to our little physics engine. In this episode, I'm going to show you how we can implement the polygon versus polygon collision detection. But first, I'm going to change a little thing, and that's adding the color. I want to change the color and initialize it to black if a shape is created as a default color. So go to shape.js, and under the this.vertices, I'm gonna say this.color equal to is equal to black, and then we don't have the bug anymore where the circle where the all the lines are just green. Yeah, there we go. Um, Now everything works as expected. Okay, so the next thing I want to change is in the simulation class, I wanna remove the circles. I'm just gonna uncomment. Yeah, just gonna comment that and say that I wanna have two rectangles, test rect A and test rect B. It doesn't matter if they are the same. I'm just gonna move the other one 800, well, let's say 850 pixels to the right. Yeah. And then, of course, we need to change everything here. Luckily, that's pretty easy to do. There we go. And now we should have only rectangles. Let's refresh, and there is probably an error. So let's see what's going on here. Canary property of undefined reading draw at simulation 40. Of course. Huh. I need to change this, of course, too. Test strict B. There we go. Let's refresh, and there we go. There are two rectangles. I think I'm gonna change something. I want to make a polygon out of here. Or maybe I'm gonna, well, I think for this example it's okay if I just move it a little bit more. Yeah, like this. And I think I can still rotate it. Yes. All right. This works, and this works too. Awesome. Okay, and then let's jump to the collision detection class, and here we're gonna create our polygon versus polygon method. This will be like this one. It's gonna be like almost the same. We can, well, I'm actually leaving it here, so I'm not gonna remove it, and I'm gonna call this method, like in the presentation in the last episode, polygon versus polygon, and it will have a shape polygon A and a shape polygon B. Okay, then it's gonna have a resulting contact. This will be our final contact where we're gonna resolve the collision. Um, yeah, then we're gonna have a variable called contact poly A, and here we gonna call the get contact point, like in the presentation. Here I'm gonna say shape polygon A and shape polygon B. Okay, and of course we need to do the same thing for the contact polygon B. Yeah, and the same thing we need to do for the other shape. So let's copy that. This will be contact poly B, and this is the other way around. Shape polygon B, shape polygon A. And before that, or let's say between them, we can make a check and break out of this method early. And here we're just gonna check if contact poly A is null. And if it's null, then, well, we return null. So if there's no contact point in poly A, there will be no intersection, basically. Yeah, and the same, and it's gonna be the same with this one. If contact poly B is null, then return null. Okay. Just making sure that I got that right. Yeah, that seems to be good. Now we're gonna check. Well, we are going to find out which of these is the best one. And we're gonna do this by comparing the depth value. And if the first one, the A, is smaller than B, then we're gonna create our manifold. So resulting contact is equal to new collision manifold. Here we say contact poly A dot depth, then contact poly A dot normal, and contact poly A dot penetration point. Okay, and if it's greater, then you say resulting contact is new collision manifold. Basically the same, but for polygon, for contact poly B. So I just can copy this. Let's say here contact poly B, contact poly B, and contact poly B. Okay, and then we're gonna return the resulting contact. And that's it for the polygon versus polygon method. Okay, now we are going to implement the get contact method. And for this, I'm just going to show you the presentation again. 1 second. There we go. So this is our get contact method. We need to cycle through every normal and call the find support. Call the find support point method, and that's what we're gonna do. We will cycle through every edge, called the find support point method. If there's no support point, then we're gonna return null, and if not, we will check or we will find the best support point. So we first need to store a minimum penetration. We set this to really high number. And then if there's a support point, we will check if the current minimum penetration is greater than the penetration depth of the found support point. Then you're going to set the minimum penetration to the found support point penetration depth and yeah, create the contact for that. Okay, and that's what we're going to do now. So, in the code, we say static get contact point. Here we say shape polygon A and shape polygon B. And then we're gonna define a variable called contact. This will be null. Then we will say the minimum, the start minimum penetration penetration that is number dot max value. So it's maximum, the max value basically of a number in JavaScript. There are equal possibilities in C# or in Java, for example, also in C++. So you can use yeah, these methods there. Yeah, and then we say in the for loop, I is equal to 0. So we're gonna just cycle through every normal of polygon A. So small lowercase letter. Okay, and then I'm gonna say here point on edge, like in the presentation. This will be the current vertice of polygon A. Yeah, that means here vertices I, and then the normal on edge, and this will be shape polygon B normals of the index. Okay, then we're gonna call the support point method. Here we're gonna say also this dot find support point, and here we say normal on edge, point on edge, and this is gonna be shape polygon B dot vertices. Okay, and I made a mistake there. This needs to be shape polygon A, not B. Okay, this is looking good so far. Yeah. Okay. Then, if there's no support point, we will return null. Oops. Here we go. Return null. All right. And if there's a support point, we say if support point penetration depth is lower than the current minimum penetration depth, then we say the new minimum penetration depth is the depth of the support point. Okay, and then we're gonna create the contact. And if there's a new better depth, then the contact will be overwritten, so it's gonna be fine. Here we say new collision manifold, and this will be the minimum penetration depth. Then the normal on edge and the support point dot vertex. Okay. I think didn't we did not define a support point class now, but we're going to do this yeah, in some minutes when we defined the spline support point method. Okay, I'm just gonna check that's right what I did, but it looks pretty good. Yeah, well, it's not gonna work anyways. Like always, it doesn't work. It doesn't work on the first try. Then let's go to the next method, and this will be the find support point method. I'm going to show you this in the presentation again. There we go. Okay. And in this method now, we are doing some math here. We will calculate the depth of every of these vertices from the other shape. Like we're gonna do this for this one, for this one, for this one, for this one, and for this one. And like in the get contact method, we will store the best point with the largest penetration depth, and this will be this one in this case. And yeah, we're gonna return then this best point. Okay. So let's jump back. There we go. Okay, so static find support point. This will be normal on edge, then point on edge, and the other polygon vertices. Okay, then the current, I'm gonna call it current deepest penetration 0. Then the support point, support point null. Then we again iterate through this time the other polygon vertices. So again a for loop. Okay. Then I'm gonna say let vertice is other polygon vertices at the index of I. Then the vertice to point edge, I'm gonna call this. This is the direction vector from the point on edge to other polygon vertice. And this will be, yeah, I'm gonna call it vertice to point edge, and we can calculate this by subtracting point on edge from vertice. So vertice and point on edge. There we go. It's the formula I showed you. And then we have the penetration depth is the dot product from the direction vector dot with the normal on edge, and that's it. One note here. I will scale the normal here to -1, with -1, because let's jump back to the presentation. Because this value here is negative, and I just want that to be positive. If I project this point here or this direction vector onto this normal, because this is going to be in the opposite direction, this normal, this thing will be negative, and I want to set, or I want to have it positive, because it's easier for me to check if the current deepest penetration is the deepest one. I just need to find the largest value. And yeah, but of course you can set it like this, but you need to change the if statement later, where we're gonna check. You need to find the most negative value. Here I need to find the most positive value then. And for me it's a bit easier to understand if I need to find the most positive value. That's why I'm gonna scale this one with -1. So I'm just gonna say here, oh, of course I need to change the, yeah, I forgot that again. For this, I'm just gonna say here in the dot product scale, the normal with -1. And that's it. Yeah. So, yeah, this will be the easiest. I mean, for me, it's the easiest if I'm just gonna search for the largest value and not for the most negative value. Okay. Then we have this one. And I think now we can do the if check. If the current penetration depth, or the calculated penetration depth, is greater than the current deepest penetration, this is 0. So if that's larger than 0, then we're gonna set the current deepest penetration depth to the penetration depth, to the new one, and we are going to set the current support point to a new support point. And this will be vertex, the current vertex, and the current deepest penetration depth. You can also set penetration depth to here. It's going to be the same. I just let it like this now. Okay, and then we can return the support point. Nice. Okay, so now we need to define the class support point. This is pretty easy. Just say class, outside of the collision detection class, and we say class support point with a constructor. Here we pass vertex and penetration depth. And this is just the vertex again. And this must be a equal sign. Okay, so let's see if I did everything right. Just gonna save the collision detection, and I'm gonna try if I can run the physics engine without without having an error. So just refresh. Okay, this works. Now we also need to change something in the simulation class. In the simulation class, we need to call the method. And here I'm gonna, I will create a for loop already and loop to all of the shapes. Of course, we only have these two, but I'm thinking about adding a third one too, and then we need to loop over all shapes. And yeah, I'm just gonna add the for loop now because we need it anyways later. Okay, so this will be I equals to 0, smaller than this dot shapes. Oh yeah, of course. We don't have a array now. Okay, I'm gonna add this too. This will be a bit of a longer episode. So this dot shapes is a new array. Then I'm gonna say this dot shapes dot push, and I'm just copying this one here, put it in here, and the same for the other one too. There we go. Okay, now we can loop over the array. And I just can copy the for loop again, format it a little bit, change this to y. Then if I and y are the same, I'm gonna continue. So I'm not gonna compare the same shapes with each other. And then I say, let's say object A is this dot shapes, and then object B is this dot shapes, and then I'm gonna call the collision detection with collision detection polygon versus polygon. Here I'm gonna say object A, object B, then I'm gonna print console.log result. If there's a result, we have a collision. Okay, but I can tell you it's not gonna work. If it's working, then I'm be really surprised. So let's see. And there we go. We have a error. Support point is not a constructor. Okay, let me check. Okay, so support point is not a constructor. This one, of course, yeah. This needs to be a upper letter. Then if you run it again, you will see another error. Cannot read properties of null depth. This is in collision detection line 52. This is here. And this is the collision no, that's the contact point. Of course, yeah. This is going to be penetration depth. So I forgot again to change the display, the monitor. Yeah, it's at line collision 52. and this is this one. And this here is a support point, and there is no depth because we call it penetration depth. Or is it? Okay, let me check this. I'll be back in a second. Okay, I made a serious mistake or error. This needs to be null. There we go. And I think I made that error somewhere. Yeah, there. We also need to check if that's null. I think that's it, hopefully. Okay, so let's go back to the browser and go again. And there we go, we have another error. And this time it's going to be canary properties of undefined draw in simulation. This is on line 56. Right. Okay, of course we need to loop there too through the list. Luckily this is a easy fix. I'm just gonna copy this line. Oh, and I forgot it again. Damn it. Okay, so basically we are drawing here the test rect, but we have a list of shapes now, so we're gonna replace this one with cycling through the list of shapes. So I'm just gonna copy the for loop, a bracket there, and I'm gonna say this dot shapes the draw. Okay. Good, then let's go back to the browser, and there we go. We can see it's already working. There's no collision. The other, maybe I can see where it's. This is HTML 59. I'm gonna remove this line too, because I just want to see the collision happening. So I'm just gonna remove the console logs here in the event listeners. I think this is everything, right? 59. 9, yeah. Okay. Okay, then I'm gonna go back to the browser. Refresh. Okay, so there is no collision happening. And now, yeah, of course I forgot that. We can't move the shape because we have a list now. So I'm gonna do that too. Okay, this is going to be a little bit of a boilerplate code. Yeah, I'm gonna say here this dot shapes on the first index will be moved. And I'm gonna copy this, and hopefully it does work this time. Seems like it won't work for me. Well, okay, then I'm just gonna replace it like this. There you go. And then the same thing for the other shape, but this is going to be the first index. Well, I mean the first element, the second element of the array. Okay. Okay. But now it should work, right? So let's check if it's moving. Okay, that works. Let's start rotating. The other one rotates too. It moves too, but it rotates also. Okay, now I'm gonna move this rectangle into the other one, and I hope it's gonna work. If it's working, then we will see something else than null. So let's see what's happening, and we will see nothing. Collision is not detected. Okay, so sorry for the mistakes, but this is the most complicated part probably on the whole physics engine. I'm gonna look at it, and I'll be right back if I found the error. Okay, yeah, I made a well, of course, an obvious mistake. I forgot to add the return statement for the get contact point method. So just add return contact here, and then it's gonna work. Okay, let's jump right back to the browser, refresh, and see if it's working. I mean, of course it's gonna work because I tested it. And there you go, we get information when the two rectangles are colliding, and when I rotate the rectangle, it's still working. Now there's no collision. Now there is a collision. Can also try the other rectangle. There we go, there's a collision. I'm gonna rotate it now. Let's see, there's no collision, there's a collision. Okay, awesome, that's working. Now I think I'm just gonna add a new shape, and this is going to be a rectangle. Sorry, not a rectangle, a polygon. I want to add a polygon, and this is going to be which values? Mm, yeah, let's say the vector 2, and I'm gonna say 0, 0, 0, then another one, 0, 100, and another one, say 150. Let's see if I get something useful. Ah, okay, that's interesting. Um, my normals are now flipped. Um, yeah, I don't know why. I'm gonna find out. I'll be back in a second. Okay, so the reason why I just did the rectangle backwards. That's the reason. Pretty simple. Okay, so the code for the triangle, I mean, looks like this. This is the polygon, and I'm gonna go back to the browser to see if that's working too. So if there's a collision, we get information. The other nulls are from the existing collision between the two rectangles. There you go, we have a collision here, so it's working for polygons too. Awesome. And now for the last part of this tutorial, I think this tutorial is already long enough. I'm gonna make a new episode for this, and in the next episode we will push the two the two polygons apart, like we did with the circles. Okay, so I hope that was a bit well, not that tedious. I hope. I made some mistakes, but yeah, you always make mistakes if you're doing this. And yeah, but we have a functioning collision detection at least. Alright, and in the next episode, as I said, I'm gonna push these things apart, and then we got quite far in our tutorial. This is one of the most difficult things here to do, and if you get that, then we will be really, really far, and the next episodes will be easier. Okay, then see you in the next one.